We got Dave Franzen and Kaylee Gash coming up. Dave is our NDSU Extension Soil Specialist, and Kaylee Gash is our Assistant Professor of Soil Health. Little thing about Kaylee and me, we go way back. We went to school together in Wyoming, so we both got our PhDs down there. You know, maybe we could start out, and it feels silly for me to ask this question because I feel like I should know the answer, but let's get some clarification on why is managing the soil for soil health or other reasons important, Kaylee?
Oh, that's for me.
Yeah, sorry, you just got up here and you're all...
Well, the soil is the foundation of plant productivity and terrestrial productivity. So if our soil isn't healthy and functioning, catching water, cycling nutrients, regulating those pest communities and the beneficial microbial communities, then we don't have a crop. So that's my simple, straightforward answer. Soil's important.
Any additions to that, Dave?
Yeah, so when the idea of soil health first came out of Minnesota, I was like, this is pretty foo-foo. And
Careful, Dave.
no, I'm serious. But then the more I started working with this and working with farmers, remember what farmers are telling me, that fields that had a manure history just seemed to yield so much more, and they seem to be more resilient, and the people are trying to catch up using commercial fertilizers, and they never can do it. They have crusting issues. Fertilizer can't help with that, and they have to use more fertilizer. And then the testing we've done on here that soil conservation and soil fertility are intimately related. It would make a big difference on the bottom line. It makes people may or may not be concerned about climate change, but what we have, we're not this wonderful area that has the same weather every year. We have drought, we have flood. In extension, we have a drought call in the morning and a flood call in the afternoon, and so we have this up and down. And so you need fields that are resilient. You just can't rely on the federal crop insurance all the time. So these kinds of fields are more resilient. You see that by working with farmers that have managed so that their soil health is just so much better than their neighbors, that they just cruise along, and their neighbors are just hyper one way or the other, whether it's wet or dry, and these soils that have good soil health, the waves are a lot lower.
So for somebody who doesn't know a whole lot about soil, except that it holds the pathogens I work with, it still looks pretty good. I mean, it looks black. It looks, from my eye, it looks healthy, but I know that's not the case necessarily. And I know we've lost a lot. So what have we lost in soil over the years?
Me? You?
You can go first.
Okay, so I'm a historian. I kind of get into this kind of thing, and I really didn't think about it. I knew we lost a lot, but really only about 10 years ago I really started digging into it, no pun intended. And when you look at, there's some old soil surveys that were published in the beginning of the last century, 1902, 1903, and they talk about feet. They talk about feet, not just 1 foot, but feet of very black soil. And you look at some of the publications from that area, and they talk about really black soil filling in the ditch and the least amount of wind. And Dave Hopkins has told me that some of the soils were described back then as billowy, like they were almost cloud-like when you went through them. It's just this billow of dust as you go through the field, that they were just so loose and wonderful. And then we turned them over with the wrong side up, and as soon as we had a wind, they started blowing. So these soil surveys talk about anywhere up to 3 feet of really black soil. The 1903 Cass County survey, county north of where we are right now, describes some fields as having organic matter in the plus 7% to feet, 2-3 feet. And then the layer underneath it that we would describe as a B, that would still have like 4.5% organic matter soil. These are really deep soils that hadn't been disturbed for 10,000-15,000 years, depending on when the glaciers moved out. And right now, you've dug holes out there. What do we have, 6-8 inches, something like that? It is not that much. We're a generation away from farming subsoil completely.
And I think that's this year has been a really good year to notice that, especially in the areas that have a little bit more topography, because as I've been driving around just the last few weeks, you can see areas where the soybeans look like somebody took a blowtorch to the hilltops, and it's just because the topsoil has eroded on those positions of the landscape over the years, and there's just not as much deep, rich rooting material that can hold water and support the soybean plants. And so I think even though on the surface it might look black and beautiful, that topography and the erosion history has really influenced the crop productivity and variability across the field. And that's really been noticeable this year.
We had a field day. We had a field day up north by at the Forest River Community. We hosted the land judging contest down there a few weeks ago, and then Caitlin Landis, the county agent in Grand Forks, had a field day up there. Invited farmers in, and one of the pits, just by fortune, had a buried A horizon from probably back in the 30s. You know, when they had one of those big storms that moved feet of soil.
So buried topsoil down there.
Yeah, buried topsoil, and so it had this much junk up on top that was around 2%, and then this foot and a quarter, something like that, of just real black layer, and that was the old A horizon. It certainly had been eroded some before that event, but it hadn't been eroded certainly completely. And I took a sample of that for organic matter content, and the lab came back. It was 5.9% organic matter in that buried A, and the soil all around it for miles and miles was like 2%.
Oh, interesting.
But that's the way that's what farmers used to farm. That's why this area would grow 40 bushel wheat in a year with adequate moisture, with no fertilizer, with crappy equipment. Look around. And questionable seed, 40 bushel it would make. That's why, because the fertility was all there to support it.
Okay, so we don't want to lose any more soils. We know they're valuable. We need them on the hilltops. We need them in the low parts of the field. We need the organic matter. How do we go about preserving that soil? And what soil management practices can we use without losing yield? I mean, we hear that commonly, you know, that you might lose yield, but it can be done maybe without losing yield. So I don't know, Kaylee, do you want to start with some approaches?
Yeah, I mean, I think to me it comes down to two basic approaches, and there are various versions of each. One is just reducing the tillage, whether that's thinking about reducing the intensity or the frequency, minimizing the space, the actual kind of footprint of the disturbance. So maybe you're considering more of a strip till situation, maybe you're just backing off and doing less tillage, maybe more shallow tillage. There are lots of versions of doing less disturbance to the soil. And that's good because that leaves residue on the surface, leaves the soil protected to resist those erosion events, whether it's windy, water erosion, whatever. And then, you know, not only so that's kind of keeping the soil, doing everything we can to keep the soil in place, but then on top of that, the second approach is just maximizing plant productivity. Plants are going to help build and nurture the soil and protect it as well. And so so that takes into account the rotation considerations, what kind of rotation can maximize that plant growth throughout the year, and then maybe can you incorporate some cover crops, or what kind of rotation would accommodate leaving more residue on the surface. Those kinds of things. So to me, it's simple, right? There are two things: minimize the disturbance and maximize plant coverage through time and space.
Okay, so a reminder to everyone: if you have a question, put it on a note card and hold it up. And Kyle isn't back here. If you're joining us online or at one of the RECs, put it in the chat or the Q&A, and we will get to it. So how do I know if my soils are biologically active? I work with biology, the pathogen side of biology, and I have a handle on that. But what about all the other biological processes and organisms?
I can take that one.
Oh yeah, you take that one.
So it's hard because a lot of soil biological activity is microscopic and happening at like an elemental or chemical level, and so it's hard to know that that's happening and to trust that it's there. So I think about the things that are supporting that activity, so the food source, the habitat. If those things are intact, then you can count on the microbes being there, doing their thing. And if they're there, then the upper levels of the food chain are going to be thriving as well. And if you keep moving up the food chain, you eventually get to things that we can see with our eyes, like beetles and earthworms. And so I think about kind of those two bookends. The start, where does it start? What kind of residues, root inputs, plant inputs are going into the soil? What kind of habitat is the soil providing? Is it porous? Does it allow air and water exchange? If those things are in place, then you have all of the parts that are there ready for to support the microbes. And then I think about the other bookend, sort of like the large organisms that rely on the smaller organisms through the food chain to support them and cycle material and nutrients to feed them. And so that's what I'm looking for. Where are the plants growing? Where are the roots penetrating in the soil? How are they, what kind of volume of soil are they influencing? And then where are those signs of the larger biological characters that we are familiar with and we don't have to have a microscope or a fancy test to detect?
So no counting for you.
I do plenty of counting, but I agree. It's usually the crew who does the counting. I count them while they count the things that we measure.
So moving on to a question from the audience. If we were still farming the soil that was present in the 1900s, do you think our pesticide, insecticide inputs would be lower?
That's a historian question.
That's a philosophy question, Dave.
Yeah, so I don't know about the pesticide insecticide. I really don't know what that would be like. I know that Andrew freaks out when there's residue because there's a opportunity for scab. But I also remember the 90s, and it really didn't matter whether you were no-till or whether you beat your soil to death. Everybody had scab. So I mean, what's the big deal? So I don't really know. As far as the fertilizer inputs, they certainly be lower. Most certainly be lower. I mean, even in our present day nitrogen recommendations, we have a real life, really tested credit or implied credit for long-term no-till, 6 years or more continuous for nitrogen recommendations, just based on that. And the other interesting thing, and this I don't know, this is almost anecdotal, but I'll say it anyway. But working with long-term no-tillers over the years, and especially the ones that started it out in their neighborhood, they don't use any more phosphate fertilizer than their neighbors. In fact, in some cases they use less. But their soil test P levels are always high. I mean, not outrageously high, but high, and their neighbors are struggling along with very low. But I think they inherited their neighbor's fertilizer because it blew on them, So I'm sure Ken out here benefited from the neighbors blowing soil onto his field. So you got some phosphate, and you got some potash, and you got some nitrogen. You probably got some weed seeds too, maybe some SCN, but at least you got the phosphate. So in the future, that's going to help you out a lot. That happens a lot.
So we've heard talking about that blowing soil, Dave. I remember up in Walsh County, maybe a month ago, we were at that field day. You talked about the cost of 1 inch of soil, losing 1 inch of soil to a farmer. And can you go through that again, or what is that?
Yeah, so I don't remember exactly the number, but if you lose an inch of soil, there's a few things to keep in mind. That there's 2 million pounds of soil in the top 6 inches, and let's just say the organic matter is 3%. So that means if you multiply that times 0.56 or something, or 0.58 to get organic carbon, whatever that number is, divided by 10, and that's how much nitrogen is in that soil embedded in the organic matter that will be expressed during your farming career. So that's gone, so 1/6 of that calculation is gone. Also, there's 2 million pounds, almost always 2 million pounds of P2O5 in 6 inches of soil. So if you lost an inch, you've lost 1/6 of 2,000 pounds. Is that what they said? There's 2,000 pounds There's a ton. There's a ton of P2O5 in 6 inches of soil. So you've lost that. Plus, the soil test K is given in parts per million, and so if you do that calculation, you've lost that K too. So it's in the hundreds of dollars. So you lose an inch of soil, and a lot of farmers lost an inch of soil this spring because it blew for several days continuously, 24 hours a day, never stopped. The 22nd of May through the 24th was the worst. And so all that's just gone, and you're not going to get a bill for it in the mailbox, but you'll pay for it over time. A little story. So we had a group of farmers from Kazakhstan come in about 15 years ago, and they want to talk about sugar beet nutrition. And so I'm in a room for them with an interpreter, and they asked us what the fertility program for our sugar beets was, how much nitrogen we applied. And I replied that we use somewhere about 100 to 120 pounds of nitrogen an acre, and we get, at that time, maybe 24, 25 ton of beets and 17, 18 sugar, something like that. So they covey together. And they said that their program was 200 pounds of nitrogen per acre, and I just kind of laughed. I said if we put on 200 pounds of nitrogen per acre for our sugar beets, we'd have beets the size of pumpkins and sugar content of about 12%. And they covered up again and said that's how much nitrogen they had to apply in order to get the same yield in sugar that we did. So, those farms have been farmed for 2,000 years. They lost their organic matter 1,900 years ago, and now they have to put on almost half again as much fertilizer as we do to get the same yields. And if you lose your topsoil, you'll be doing the same thing.
Wow, we don't want to do that.
I hope not.
Unless Ken's going to get it, and then.
All
We
right.
have a couple questions, huh?
Yeah, sure. So first one is, how long can farmers glean residues before it impacts soil health?
Well, if you take off all the residues every year, then the soil health will pretty well plummet, because you're not really feeding it. You have the roots, of course, and the roots contribute a lot to the organic matter, but you're losing all that top stuff. So in our wheat fields, for example, we're taking off maybe about a ton an acre of residue, but there's probably about a ton an acre left. And so I don't think we're really hurting ourselves that much. People are taking all the stalks off like you would with silage. I think over time that would certainly hurt you. If you're just taking what would you call it? What's it called? Not combineage, but something like it. Just whatever goes in the combine goes in a basket or something, and some kind of trailer. And leaving quite a few stalks, then I'm not sure that would hurt you very much. But taking it all off, I think, over time. But once in a while, like you're in extreme condition, you got cows, and you need income and things like that. Once in a while, it's not going to kill you. But if you do it all the time, that's a really bad thing. China right now has gone into a program, and always before they've taken all the residue off their fields. And it's one of the reasons they don't have scab, is that they take all the residue from all their fields, all the stalks, all the wheat, everything. But they're finding out that their soils are becoming concrete, and so they're in a national program now to leave residue in the field. How that's going to happen, how that's going to work out for them, I have no idea. But they're recognizing it, and so there has to be some left out in there. It's one of the problems with beans on beans. It's just because you're growing a legume out there it's not a soil enriching crop. It's actually a soil mining crop. But you don't see it because you're not applying nitrogen to it, but it's degrading the soil faster than another crop would.
So I could just buy a product, though, right, Kaylee? and apply it to the field and solve a lot of these problems. She's going to punch me later for this question. But, those treatments, the things you can apply to the field, how efficient or effective are those?
Well, when we're talking about rhizobia, that's one thing. So we have the science of applying and using rhizobia as an inoculant down. That's a really good approach. But when it comes to things like mycorrhizal fungi, microbial consortia or some kind of biostimulants. We don't have a lot of consistent evidence that those applications are effective. And they might be in 1 year, in one field, they might provide some kind of little boost. But across the board, it's hard to say that those treatments are really effective. And the reason is just because we have such mind-blowing diversity of beneficial microbes in our soils naturally. Microbes are constantly moving in the wind, on equipment. They're always recolonizing areas, and the ones who are best adapted to those local conditions are going to survive and thrive. And so if you could imagine then sort of a slurry of foreigners being kind of dumped into a soil that's full of competitive, well-adapted, very fit microbes, there's going to be maybe a little bit of a battle, maybe a little bit of a yield boost, because along with adding microbes, you're probably adding a little bit of fertility in biological form. But then the locals are probably going to win out. And so we have a lot of beneficial microbes in our soils, and I'm a fan of just supporting the ones that are there that are best adapted to those conditions with those practices that we've been talking about.
Interesting. So maybe I can ask you, Dave, you've mentioned China, Kazakhstan, yes, maybe? We talked a little bit about the history here in the valley. Is there a part of the world or a country that is really leading in soil health, that's really stopping the erosion, no pun intended, of the soil health that you would look to?
Well, one of the problems in this area is it was settled by people that came from areas that didn't really know what wind was. And so, I mean, it was, if you're in a Rhine Valley someplace or in Bergen or somewhere, that and they're farming in those secluded valleys with a stiff wind. I was out in Utah one time, and they said there's gonna be a little bit more wind tomorrow. It's gonna be 2 miles an hour, and I just looked at the wind. I thought, are you kidding me? And so they're okay. But then they came over to here, and they'd write back and say it just, the wind blows every day. And we know that. We live here. You know, it's just a rare event when we don't get any wind sometime during the day. And so it was totally a different type of a system. And certainly the natives couldn't tell them any different because they'd never turned the soil over. It's a kind of a taboo for them to do that. So so it was a new experience, and unfortunately, you know, what's done is done. But they weren't stupid people. They were just doing what the books told them to do, and what they've learned from their fathers and grandfathers and whoever else.
So is there an area in the world that deals with issues like we're dealing with that maybe is ahead of us that we can learn from or see observationally how it's working?
You know, I think we're about as far ahead as about anybody in doing it because I don't know, we have the system to support it. We have the extension system. There is no extension system like this anywhere on Earth. The Chinese have an extension system, but it's really just a sales arm of the government. That's all it is. They're not really independent and unbiased, you know, that kind of thing. So, so there really isn't. In the 1950s, the Chinese plowed up the northeast province in their country, which was kind of what the Imperial Game Preserve before, and they call it the Black Soil Zone, and I suppose it was in the 1950s. They had teams of Red Army out there, you know, with pulling plows, you know, with by hand, and turned the whole thing over, and then of course the wind blew off Mongolia and blew a lot of that black soil away. So now, when we were over there a few years ago, you can see lines of poplar trees around every field. They were all planted in the 70s, probably after the Cultural Revolution, to stop the wind, and now they're starting to experiment more into no-till, strip-till, those kind of things to preserve what's left. They still call it the Black Soil Zone, but it ain't. You know, it's more like a kind of a, you know, it used to be a Black Soil Zone type of thing. And that happened just over 50 years.
Wow.
But I don't think anybody's ahead of us right now. And to give the farmers credit, the idea of this soil health thing, and certainly the no-till that we see in the state, came from farmers. It didn't come from USDA. It didn't come from Extension. It came from farmers looking around the table at each other and think, my God, if we don't do something, our kids aren't going to have anything to farm. And so, the Beach Boys out in the southwestern part of the state, Joe, the whole Manitoba, North Dakota, no-tillers, it was the farmers that decided that this really had to happen. And so, we're kind of piling on them now. They've set the stage. They've shown that it will work. It shows that it can build soil back. And, in 40 years in the southeast part of the state, some of those organic matter levels are 7.5%. They're not 3 feet, and they probably won't be for 3 or 4 generations. But dang, that's a really good start.
Okay.
That'll be good. I
Good.
think this afternoon at the Share Farm, we'll talk about some of those practices and how to implement them and what it means for soil warming and moisture as well. But we're in our last 5 minutes, aren't we?
Yeah, we're about out of time, but we didn't get to all of your questions. So if you have questions, feel free to email any of us and we'll try to answer you independently. So it's time for your top picks. What do you think? Do you have a top pick, upset pick? 3 picks?
I have 3 picks. Can I pitch 3? I've already talked about 2 of them.
You've got
so
3. You got 3
Okay.
picks.
Protect the soil, feed the soil, diverse, healthy, nutritious diet, and then just commit to a long-term soil health management plan and be patient. I think it takes that long-term commitment and the patience to let it play out and serve you back. Those are my picks.
Okay, so mine are, remember the past, can't do anything about it, but at least realize that something pretty horrible has happened. The second is that where are you at right now? And are you willing to take a step? And it doesn't have to be both feet into the pool, jumping in the deep end at once, but just making a movement. And the third thing is that don't expect a recipe from anybody. That listening to others that are in various stages of transition or those that have been in it for a long time, but don't try to copy everything that they do. To try to adapt whatever those ideas are to what you think is possible on your farm and what your family and your landlords will stand, and go from there.